Our current chapter, or our next chapter now, is going to be introducing sort of a big part of calculus, which is derivatives. And we're going to start with the definition of the derivative. When we're actually in class, I'll go through how it was developed, but right now you're just going to be working with this formula right down here, this formula looking thing. We call this the definition of the derivative. So if you're ever asked to use the definition of derivative to find or to derive a function, that's what you're doing. So what is a derivative? The derivative is the slope of a tangent line. And so if you have a function, any old curve of a function, I'm just drawing kind of a curved one here, a tangent line is a line that hits the function at one point. And so when we're finding our derivative, we're finding the slope of that line. And the derivative has a couple of different ways of writing it. One way is this f prime of x. That's not a 1, it's sort of like a little apostrophe maybe looking thing there. An apostrophe, that's f prime of x. That's the first derivative of a function with respect to x. It's also written as dy dx, read exactly like that, dy dx. And that's the derivative of the y function with respect to x. And so on any given day, you could use either one of these interchangeably. Typically, when we're dealing with the definition of the derivative, we'll work with the f prime of x. But oftentimes, you'll see dy dx, especially when we get into the shortcuts, which comes next. All right, so let's, if you need to pause to finish writing stuff down, please do so, but we're going to jump right in and start using the definition of the derivative to find the slope of the tangent line. And we'll start by doing it on the function, and then when we get to our next few examples, we're actually going to be evaluating the actual slope, okay? So I'm going to show that definition of that derivative. What I usually do when I'm doing it, especially when you're getting started learning this, is just rewrite the function as f of x. That's 4x plus 5. And then in this, I need to rewrite the function as f of x plus h. And we remember from, hopefully we remember from our previous chapters, our first chapter, in fact, we did a review of functions. That just means replace x with x plus h. So this is 4 times x plus h plus 5, or I could write that as 4x plus 4h plus 5 if I distribute that through. So once I have my f of x and my f of x plus h, what I can do is plug it into this formula. So f prime of x, the first derivative, is equal to the limit as h approaches 0 of f of x plus h minus f of x. I have to put that second part in parentheses so that I remember it's minusing the whole function, and so I want to make sure that I don't forget to bring the negative through to both parts, all over h. And we learned that to take a limit, what you do, the easiest way to take a limit is to plug in that value. What happens, however, when I plug in that value is I'm going to end up with 0 over 0, which we learned in our last chapter that should raise, remember, a red flag there. That's a problem. So that means I must be able to do some simplifying to clean this up. And so I didn't take the limit yet, so I'm going to leave that limit there, but I'm going to clean this up. This is 4x plus 4h plus 5 minus 4x minus 5 when I distribute that through all over h. The 4x's cancel out, the 5's cancel out, so now I'm down to the limit as h approaches 0 of 4h over h. Well, those h's also cancel out, so now I'm down to the limit as h approaches 0 of 4. And one of the other things we learned about limits is if I'm taking a limit of a constant, then the limit is that constant. So my first derivative, or my slope of my tangent line to this function, is 4. And that's about it for those problems. So let's work through another one. My function is already written in f of x, so I'm just going to do f of x plus h, which is 5 times x plus h squared minus 1. So I just replace x with x plus h. Don't for a second think that this is just x squared plus h squared, because it's not. This is 5 times x plus h times x plus h minus 1. So I have to FOIL that through. I usually do this part first. So this is 5 times x squared plus xh plus xh, so plus 2xh plus h squared minus 1. And then finally I'll distribute that through 5x squared plus 10xh plus 5h squared minus 1. Now that I've done all my preliminary setup, I can find my first derivative, and f prime of x is equal to the limit as h approaches 0 of f of x plus h, so that's this whole big thing, f of x, or sorry, 5x squared plus 10xh plus 5h squared minus 1 minus 5x squared minus 1 all over h. And again, if I take my limit, I'm going to end up with a 0 over 0, which again is going to, should raise, I always write that in, remember that raises a red flag, something's wrong with that. So I'll do a little bit of cleanup. As we do these definitions for the problems that we're doing, you're going to start to see some similarities that happen in the algebra. Things clean up pretty quickly. I get 5x squared plus 10xh plus 5h squared minus 1 minus 5x squared plus 1 all over h. So the 5x squareds cancel out, the 1 cancels out. You know you're doing this correctly if you only have terms with h left in it. Again, for what we're doing, I still didn't take the limit yet. I tried earlier. Remember, it didn't work, so I'm going to continue to write that limit. So this is 10xh plus 5h squared all over h. Everything has an h in it, so I'm going to go ahead and pull an h out of the top. So this is h times 10x plus 5h all over h. That h cancels out. And now I can actually take my limit. So the limit as h approaches 0 of 10x plus 5h, that just means I plug in 0 for that. It's actually going to cancel out that term, and that leaves me with 10x. And so my first derivative of this particular function ends up being 10x. Now notice the previous one had a constant value. That's just because of the initial function. This one has a variable in it, and that's because if you think about what a parabola looks like, depending on where I draw my tangent line, the slope is going to change. So if I plug in something negative, you know, or on this side of it, I'll get a negative. If I plug in something on the right-hand side of the vertex, I'll get a positive slope. Where this original function, if you think about what that looks like, that's just a line with a slope of 4. And so no matter where I try to draw the tangent line, the slope is going to be 4. So it all really depends on the original curve. What I'd like you to do is pause the video and see if you can do the next problem. And then when we revisit, you can kind of take a look and see how you did. But go through that process of starting with f of x, plug in x plus h for any x, and then work your way through and see if you can find that slope of that tangent line. If done correctly, you should have ended up with negative 8x in the end. I do have all the work shown here, so if you didn't get that, maybe look back and check and see if you can find your error in there. A lot of times errors happen within the signs. Okay, so watch closely for your signs, dropping a sign somewhere. In fact, that tends to be, again, one of the biggest mistakes that I see in calculation errors is just messing up, like when I distribute this negative or forgetting to distribute the negative. What's going to happen a lot of times if that's an issue is you'll end up not being able to cancel out all the terms that have h's in them. So if you have stuff left here that doesn't contain an h, I would go back up and check your sign. So number 4, I'm just going to get started on number 4, and then I'm going to let you guys kind of work through it on your own, see if you can do it. But the number 4 has an extra x in there, so when you do your f of x plus h, you have to do the 4x plus h squared plus the 2 times x plus h plus 5. So when you bring that through, remember that it's got to go, x plus h has to go into both parts. So this is 4 times x squared plus 2xh plus h squared plus 2x plus 2h plus 5. And when I distribute that through, 4x squared plus 8xh plus 4h squared plus 2x plus 2h plus 5. And now I'm going to let you go on your own and see if you can put it into the formula and come up with your value. Again, pause the video and come revisit it when you are finished. If you did it correctly, you should have ended up with 8x plus 2. That should have been your final derivative after you go through that whole process of putting that in. Now on the following problems, I'm going to have you do the same thing. I'm going to have you pause the video and find the derivative, and the directions change, so we're going to end our problem a little bit differently. So don't pause just yet, but this one says find the slope of the tangent at the given point. So we first of all have to find the slope. So we first of all are going to do our f of x, which is x squared plus 4, and our f of x plus h, which is x plus h squared plus 4. And then, of course, square that, x squared plus 2xh plus h squared plus 4. Go ahead and put it into your derivative. Again, pause the video as h approaches 0 of your f of x plus h all over, minus f of x, don't forget the parentheses to distribute that negative, all over h. So again, do your cleanup, pause the video. I'll meet you back here shortly. Alright, welcome back. So you should have, when all is said and done, gotten a derivative after you've taken your limit of 2x. Because we want to find the limit at x equals 4, that means I'm looking for f prime of 4. So I just do 2 times 4, and my slope of my tangent line at x equals 4 is 8. That should make sense. Again, this is a parabola that curves here, and so at x equals 4, I should have a pretty, if this is 4 right here, I should have a pretty steep positive slope. My slope of my tangent line looks like it would be about 8. Alright, I want you to do the same thing on the next one. Again, pause the video, get your derivative, meet me back here shortly, and then we'll go through and find the slope of the tangent line at that point. Alright, again, welcome back. You should have gone through that process. F of x is 5x squared plus 2x, and f of x plus h is 5 times x plus h squared plus 2 times x plus h. Go through your whole process. If done correctly, your first derivative should be 10x plus 2, and we're interested in the first derivative at 1, so f prime of 1 is 10 times 1 plus 2 or 12. Please do 9.1 evens or odds. And then when we get together again, if you have any questions, we can go through those at that time.